In question 8, I need to describe fully a combination of two single transformations which will transform the graph of y equals cos x to the graph of y equals 4 cos of x minus pi by 3. Okay, I recall the standard transformations of curves applied to this function. And the conclusion is that it should be a translation of pi by 3 units to the right and then a vertical stretch by scale factor 4. I can use the Casio graphical calculator to illustrate this. If I select option 5, the graph function menu, and I plot to start with cos x, and the second function I'll plot to start with is cos of open bracket x minus pi over 3. Be careful to make sure you close the correct bracket. Okay, now if I select execute, and just before I select F6 to draw, I'm in radians mode, which is the correct one for this because I'm drawing these graphs in radians. Okay, now I can see that there's clearly a translation going on, but actually at this scale it's quite hard to see. So I'm going to change the V window settings, and certainly the Y minimum does not need to be minus 12, so I'll change that to minus 4 to begin with, and then select execute and F6 to draw. Okay, and what I could even do here is I could narrow the x-axis. If I go to V window, and I'll actually change it to minus 5 for the minimum and 5 for the maximum, and select execute and F6 to draw. Okay, now it looks like a translation has occurred, and it should be a translation of pi by 3 units to the right. Pi by 3 as a decimal is 1.04719 and so on. It's worth noting that because what I'm going to do is I'm going to look at the roots of y equals cos x and then the roots of y equals cos of x minus pi by 3 and see if they differ by this amount. So if I use F5 for gsolve and F1 for root, and you can see the blue curve, the original one, y equals cos x, is flashing. So if I select execute, and I'd like to scroll to the right to this root here, 1.5707, etc. That's actually pi by 2. Now to this decimal here, if I add pi by 3, or this decimal here, I'm expecting to get the root of the red curve, y equals cos of x minus pi by 3, the one just here. Okay, let's check that. If I choose gsolve again, and root, but this time I scroll down to the red curve. Okay, now I select execute, and I can look at the roots for the red curve. And if I move to the right, and again, I get this number, 2.617, and so on. Well, this number here is actually 5/6 of pi. Well, you can see there the difference between pi by 2 and 5 pi by 6 is indeed pi by 3. So the Casio graphical calculator has been helpful in confirming this translation of pi by 3 units to the right. To look at the vertical stretch, I want to first of all change the V window, because at the moment my Y minimum is minus 4 and my maximum is 4. And although that should be sufficient, I'd like to be able to see the peaks clearly. So if I change this to minus 5 and 5, and I'll add the third function, which was 4 cos open bracket x take away pi over 3, and then I move out of the fraction and close the bracket. Okay, I select execute and F6 to draw. Okay, now I can quite clearly see the peaks and troughs for the curves at 1 and minus 1 for the blue and the red curve, and at 4 and minus 4 for the green curve. If I want to, I could use gsolve and look at the maximum for, let's say, the green curve. So I scroll down and select execute. And again, you can see the y coordinate is 4. Similarly, I could do the same for the minimum, but I think it's very clear with this visual representation that I did have indeed the correct two single transformations to go from y equals cos x to y equals 4 cos of x minus pi by 3.